This problem gives us a plastic sphere of 6 centimeters radius with a charge Q minus 49 microcoulombs spread over it, and it asks us to find the electric field at 3 different locations. We'll do this using Gauss's law, which says that the electric flux through the closed surface equals the charge enclosed by the surface divided by epsilon naught. Let's first apply Gauss's law to an arbitrary spherical surface concentric with the plastic sphere we were given. I'll draw that here with this outward normal in the radial direction. We know from symmetry in the problem that the electric field will also be in the radial direction, so E dot dA just becomes E times dA. Those are scalars. And also from symmetry, we see that the magnitude of the electric field is constant over this Gaussian surface. So we can drag it out of the integral and integrate dA over the surface of a sphere to get 4 pi r squared. We can solve this for the magnitude of the electric field. It equals the enclosed charge divided by 4 pi epsilon naught r squared. Going back to the symmetry argument, the electric field is in the radial direction, so that gives us the electric field vector. It depends on the enclosed charge and the radius of the sphere. Now we can apply this result to each of the locations we were asked about. In part A, we were asked about a location just inside the radius of the plastic sphere. I'll draw that in the light red color. The electric field at that location is Q enclosed divided by 4 pi epsilon naught capital R squared. The light red sphere is inside the plastic sphere, but all the charge lies outside of it. So Q enclosed is 0, which means that the electric field inside also equals 0. In part B, we're asked about just outside the plastic sphere. I'll draw that in a darker red color. The electric field there is the enclosed charge divided by 4 pi epsilon naught capital R squared again. But this time we see that the dark red sphere encloses all of the charge on the plastic sphere because the dark red sphere is just outside of it. So when we substitute the enclosed charge, which is the total charge Q, and the values for epsilon naught and capital R, we find that the electric field just outside the plastic sphere has this value. It's directed along minus r hat because the enclosed charge is negative. Part C asks us about a point 5 centimeters outside of the sphere's surface. So little r, the radius of our Gaussian sphere, is capital R, the radius of the plastic sphere, plus 5 centimeters. The charge enclosed is still all of the charge, capital Q. When we substitute those values and calculate, we find this value for the electric field 5 centimeters outside the plastic sphere surface.